Good afternoon, and thank you for joining today's webinar from Spec Innovations, an overview of requirements management and analysis using Innoslate. My name is Elizabeth Steiner, and I will be the moderator for today's webinar. First, I would like to go over some housekeeping before we get started. During the presentation, feel free to send us questions, and we will get them answered in the workshop part of the webinar. You can also interact with us on LinkedIn through the Innoslate user group or through Twitter using the handle @Innoslate. The webinar is being recorded, and we will make it available to you after the live presentation, so be sure to keep an eye out for it in your inbox. Now I would like to introduce you to our presenter, Mike Campbell. He'll be sharing with you how to get started with requirements management and analysis in Innoslate. Mike is a risk analyst and systems engineer here at Spec Innovations. He is a veteran of the Navy, where he had experience as a surface warfare specialist and two 6-month deployments with full workups. Mike has 11 years of work experience performing risk assessment, risk management, cost-benefit analysis, and organizational functional analysis tasks. He is also attending Georgia Tech for his master's in systems engineering. Mike is an expert with Innoslate. He will help us know the ins and outs of requirements management and analysis. I'm going to let Mike take over from here, and we will get started.
O'clock hour. Good afternoon. I believe it is past the 12 o'clock hour here, so I can officially say afternoon. Today I'm going to go over requirements management analysis using Innoslate, and I just wanted to show you here the agenda of what we're going to be going over. The makings of a good requirement, how to write a good requirement, or what makes a good requirement, important requirements into Innoslate, how we can do that, and I'm going to show demos of these, of all these steps in the process of how we do this. Actually doing requirements analysis and management using Innoslate and the requirements view, creating relationships of requirements between other entities within Innoslate, as well as also between requirements, and showing how you can actually do this in multiple different ways. I'm also going to show how you can execute traceability throughout the tool, and then we'll go to what's next, because as systems engineers, requirements are not just the end-all, be-all of what we do. We actually like to take the requirements and move them into further steps within the systems engineering processes. And then I'll go over just a summary of what we've talked about, and then we'll take questions at the end. Some considerations to take into account when writing requirements or when evaluating requirements: keep sentences and paragraphs short, use the active voice, proper grammar, spelling, and punctuation. This all helps when you're sending these requirements to people who have to evaluate these, and it makes it easier for them to read and understand. Use terms consistently and define them in a glossary or a data dictionary. Those can also be used as an appendices. In some cases, I've seen those multiple times as appendices. So just using terms consistently. So instead of saying, a plant and a flower, use plant; bush or shrub, use shrub, or whichever term you like to use consistently. That way you don't have inconsistently confused people as they're reading the requirements down the road. Avoid long narrative paragraphs that contain multiple requirements. A helpful granularity guideline is to write individually testable requirements. Watch out for multiple requirements that have been aggregated into a single statement. That's very common with requirements writing. When you see conjunctions like and or, those can typically be decomposed into separate requirements. So as you're looking at these requirements, that's typically how a natural requirement will come into its own requirement in itself when you have a conjunction. When you write requirements at a consistent level of detail, the organization of the requirements at different levels allows for easier understanding of functionality, as well as satisfying, verifying, and tracing the requirement through the process. It's one of those, as we decompose into more detailed requirements, having them actually organized in a fashion that's easily understandable makes it easier on just about everybody else that's going to be looking at these requirements within the process. Avoid ambiguity and duplicate requirements that can be locked into multiple areas of a requirement stack. That also creates a lot of frustration for people who have to read the requirements and try and put functionality into them. And actually, when they come up into another requirement that says just about the same thing, it's just making extra work. So we just have to be careful of avoiding duplication and anything that can be ambiguous. And there are plenty of things to consider when performing requirements analysis and management. Using Innoslate will certainly make that job a bit easier. So importing requirements into Innoslate, there's certain ways that we can do it within the tool. We can use our import analyzer, which I'll show you here in a minute after we go through the slide. There's just a correct format that the tool actually looks for, and it uses a natural language parser to be able to bring in the requirements, set them up as a name, number, and description, and you can then actually start analyzing requirements from that point on. Like I said, there are multiple different types of imports, and I'll show them to you, but we can do Microsoft Docx, we can do Excel, we can do CSV files, we can, Innoslate can also bring in PDF if copied, or text if copied and pasted, and you can also select your formats on how you want it to be brought in. So we'll take a look at that. The nice thing about the import analyzer is that you can actually preview the import before you save it to make sure it's how you want it to look. And all requirements that are, or any type of import that's brought in is always put into requirements view, so you can actually see how it's going to be laid out. So without further ado, I will take a look. We'll take a look into this. So I made up just some basic requirements for something that I did a long time ago, wildland firefighting, back when I was in college, and I just wanted to. This is basically some requirements that were laid out on how to become a hotshot. And a hotshot is just kind of it's more of a glorified role of a wildland firefighter. They're the guys that go in first, come out last, but they work hard, they hike everywhere, and they're usually the first call to every fire that's breaking out in the hot west areas. So these are just some typical things to becoming a wildland firefighter and then actually being a candidate for a hotshot crew. So I brought these in as the basic format. So we have a number, name, description. You can add a class, but the tool will also ask you for a class. So what I'm going to do is I'm actually going to save this so I can bring it in. So I can find it. Okay, so now that I've saved that, what I'm going to do is I'm going to go to Innoslate here, and I've already created the project. Now, if you don't know how to create a project, it's fairly simple. Just go into Manage Projects here, and you can actually go into New Project and just start going from there. But since I'm already in the project, what I want to do is actually, I really want to go to Requirements Analysis and Management. So now I can either do it from here. I can import an existing requirements document, or I can go up to the menu and go to our import analyzer. And that can easily bring me to the analyzer either way. So I'm going to go ahead and just use that method. So this is the import analyzer. This is where I'm going to upload the document, and that way to look at how the document will be brought in as a requirements document. So again, I told you we can do Microsoft Docx here. If we had an Innoslate XML file, we can import it that way. An Excel CSV file, or a DOOR CSV file, or the plain text. So if we click on the plain text, you can see there's different formats of how you can bring it in. And then you can also create your own custom one. You can certainly select which class you want to bring it in. If you're not familiar with lifecycle modeling language, this is the language we use. So these are the classes that are used within LML, or lifecycle modeling language. And then you can also create the name. This is if you're going to use the plain text, PDF, .txt, etc. If you wanted to do some more, we actually have some more here using a keyhole markup language as well. So we're going to do a CSV. So what I actually need to do is go back and save this as a .csv. Yep. We're going to go to that one. Okay, so as we're looking at Innoslate and we want to bring this in, we're going to use the Excel.csv. I want to bring them in as a requirement. And then I'm going to hit the next button. Now I'm going to bring this file over here. So I need to go to my files here, look for the CSV, and I can either double click on it or I can just drag it. So I'll just drag it, let it upload. And so the upload progress is now at 100%, and Analyzer has verified it as well to be 100%. So now I want to preview it. So as I look at this, it's actually going to come in how I want it to come in. So I have the description, I have the name of the actual process, and I have the numbers that are being allotted. At least that's how I wanted to allot them. And then the classes that these are going to come in as. So it's going to bring in the original artifact and then bring all these in as a requirement. So I like that. I like that. So now what I'm going to do is I'm going to save it, and that's going to bring me, that should bring me into requirements view, which it does. And now I have my document up here, and it's a part of a dropdown. And now I actually have the hierarchy of my requirements listed here. And this is going to allow me to, I can build off of this. I can start creating rationales for why this is a requirement. I can also do what's called a quality score. We'll get into that in a little while here. But right now, as you can see, the numbers came in correctly with the hierarchy. Here's the name, and here's the description. Okay, so we've got basically everything that we've done in order to import into Innoslate. And so now, as we want, if we wanted to add, a child to this, I can certainly add the child here. So you'll see 1.3 as the next child, but I don't need to add to that just yet. If I wanted to, add after, it'll actually add to the numbers, but I don't want to add that either. So, so as we're looking at the requirement section here, there are quite a few things that are going on here. So the quality score is related to the quality checker. We can auto number if we didn't like the numbering process or if there was no numbering process brought in. We can certainly baseline our requirements as soon as we've got a foundational set of requirements we're happy with that we don't want to change and that we want to build off of. And that'll be saved as an artifact up here as well. So, and we'll show you that here in a little bit. We can certainly create multiple reports out of this. We have, a basic document, basic tabular, requirement satisfaction matrix, traceability matrix, verification matrix, and then the verification traceability matrix. Those can all be exported as a report. The report gets saved as an artifact within the database, so you never lose the data, and it also can be saved to your computer as an output. And so it's very powerful to use these types of outputs to show how your requirements are verified, traced, and satisfied. And we'll go into that in a little bit more detail here. So I believe I showed pretty much everything here. So as we go into the next slide, doing requirements analysis. So using Innoslate to analyze requirements, we're going to do it in requirements view. I showed you the rationale, and rationale is pretty simple. It's just why is this a requirement? What's the rationale behind this being a requirement? Quality score, and I'll show you what the criteria that goes behind the quality score and how we can improve that quality score. So as we're going through our requirements deck, as we look at this, like I said, there's the quality score here. What I want to do is I actually want to run my quality checker, and what this is going to do is it's going to actually read my requirements and the description of the requirement, and it's going to look for the certain languages that make up a good requirement, at least for the initial, for 4 characteristics, and that's clear, complete, verifiable, and traceable. Yes, I believe those 4 are correct. If I wanted to recheck that, I can certainly go to the entity view and double check. Yep, clear, complete, design, and verifiable. So is it a clear requirement? Is it a complete requirement? Is the design of the requirement does not impose a specific solution? It says what, not how. And then is it verifiable? Can it be tested and verified that the requirement is an actual good requirement? So in that case, what I'm going to do is I'm going to go back to requirements view. And so now this quality score will actually run against those 4 parameters initially. And so as I run the quality checker, so I can see that I've got a good score here of 44%. I can see that these need some improvement. As we're working down these requirements, I can certainly see that some need improvement. So as we're doing that, we can go back to the process I just did. So we'll go back to Entity View. And then what we're going to look, this is the artifact, my apologies. So as we go to the Entity View here, so now we have the parameters that make up our quality score. They're based off of 9 parameters or criteria, and there's certain ways that, there's certain definitions that pop up, as you can see here, as to what the parameter means, and that way you can analyze the requirement to see if it actually does meet that criteria. This is basically meant to help us improve writing requirements, as well as also improving a better requirements deck and ensuring that our requirements have been analyzed to a certain degree of criteria. So as we look at what's clear, again, this is going to be automatically checked. So yes, wildland firefighters must complete the basic fitness test to be employed for the position. That sounds pretty clear to me. If they don't complete it, they're not employed. Is it complete? Can it automatically check? I'm sorry. Is it complete? Complete represents if this requirement expresses a whole idea. That's a pretty good whole idea. So as we start doing the analysis on this, we can start to see how the criteria is going to fit within this requirement. So if we wanted to improve the score, again, these are drop-down menus. Is it consistent? Consistent represents if this requirement is not in conflict with other requirements. You have to look at your requirements deck to verify that, but as I wrote the requirements, I made sure that this was not in a conflict with other requirements, so I can certainly change yes, and as I change yes, you can see the score went up. So as we're doing our analysis, using this criteria will help us to analyze the requirement and at least give us a better focus on the requirement to make sure that it's actually a good written requirement and that it doesn't need to be rewritten by someone else or by the person who did the requirements initially. Because if it does, I mean, you certainly can do that, but at this point, analyzing requirements with these types of criteria is pretty thorough. It's substantial enough to give you the parameters of writing a good requirement and understanding how a requirement can be good enough to pass on to people who are going to actually build models off of these requirements. So that way they can understand it clearly and that you read it to be understood, that they'll understand it clearly. So is the requirement correct? So what does that mean? Well, correct represents if this requirement describes the user's true intent and is legally possible. Well, that is part of the employment job that you need to pass that test. Is it feasible? Yes. Is it modular? This is the big one. This is the tough one that seems to get quite a few yeses and nos because it's a very specific criteria for a specific requirement. So it represents if this requirement can be changed without excessive impact on other requirements. This is actually a yes. Change without excessive impact on other requirements. This is actually a yes because they must pass that test. If they don't pass that test, they cannot do any other requirement to become a hotshot. Therefore, the wildland firefighter must pass the basic fitness test. And can this be traced? Well, yes, we can certainly trace it back to the artifact. We can also trace it to the basic fitness test if we wanted to actually model that as part of the area. And yes, we can do verifiable here as well. So with that being said, that's pretty much how we can analyze requirements. Ideally, not every requirement is going to be at 100%, but you can certainly get it there based on some of the parameters. But the modular one tends to be the one that will hang you up as far as whether it's going to hit that 100% mark or not. So again, as we're doing these, you can also see on the right here we've created relationships. These were created automatically when I brought them in through the requirements view, but you can certainly add more if you thought there was going to, if you wanted to change anything here, you just add it, going through here. So now, as we're looking at this, let me make sure I'm, yep, so I did the quality score, rationale, requirements view, using Innoslate and improving the quality score. So we're going to move on to the next slide with this. So as we look at creating relationships, there are multiple ways to do this in Innoslate. We can certainly use multiple views to do this. And this allows us to create identification of a requirement being satisfied, traced, and verified. So this is going to be a little more extensive. So let's go into Innoslate again. So like I said, we can create the relationships over here. We do have popular ones that are related to the actual requirement class. These are going to be the ones that will be mostly used underneath the requirement class. So decomposes parents, it references an artifact, sourced by an artifact, which you see here is the CSV that I brought in. Or it can be traced from a statement from some other area, maybe a legal document or some type of policy document that the Forest Service may have out there as far as some of their requirements, which they do. I just don't. Couldn't actually copy that, which I want to do. So, or you can trace it to many. There are many other types of. You can trace it to an action. You can trace it to a statement. Those types of things. Usually, but anytime you see the relationship, you'll certainly see the add button over here, and you'll see which ones can be added to be traced to. So if there's other requirements that fall under this requirement or that are related to this requirement, you can certainly trace them to it based on traced from statement or whatnot. So we can certainly look at this and hotshot basic training, as we look at some of the requirements there, well, nothing really fits it, but if it did, it's as easy as doing this and adding it, and now I've got traced from a statement, even though it's the actual decomposition of this this actual requirement, which is not proper. But I just wanted to show you that that's an easy way to actually do the relationship within the entity view. Now, if we wanted to actually do, sorry, I just want to make sure I'm hitting all the notes here. Okay, so if we actually wanted to look at creating relationships in other areas, we can certainly go to the diagrams. We can go to the diagrams and we can see different diagrams that we wanted to look at. The easiest one to look at traceability is your spider diagram. You can start looking at this and seeing how things trace out, and it gives you the relationship. And that's a little small, so we'll increase that up just so you can see it a bit. You can start looking at, this is the artifact here. You can see it's a source of employment, which, the other areas over here decompose. So fitness qualification is part of the employment, and the fitness test is part of the fitness qualification. So you can see how it's actually all into this. And then, the fitness, when you click on this, it actually brings you the attributes over here, so you can edit them on the fly without having to change views for any reason. So if you wanted to change the number, or if you wanted to change the description, you can certainly do that. You can also change your rationales over here. So yeah, it's consistent, correct, yes. And this right here is when the quality score actually runs its quality checker initially against the 4 parameters. It'll actually give you a suggestion on how to improve that parameter. So the design, it said the design is a no, so it said the requirement may not be directed to a given system or service. So yes, I would probably have to improve that as I looked at writing up that requirement. Sure. I would have to go back to the description. Any candidate looking to become a wildland firefighter shall not show up out of shape. Well, that's actual. That's not. It says shall, which could mean that's that's a specific requirement. But what determines out of shape? And that's probably why this was a no, just because you can't really determine. What's really out of shape in the terms of being able to perform the basic test. So, so again, we can certainly show traceability here. We can also, if we wanted to add more, we can add another point here and trace it, and then we just add the relationship that it's traced from, and now we can start creating the relationships here. It's an easy way to do it. It's certainly functional, and then you can just trace it off of here. So we can do it as the hot shots PT guide to employment. PT just means physical training. So you can certainly do something like that as an action. As Hot Shots Fitness, it's traced from this area, this guide to employment. So there's many easy ways to trace this out. Now, if I wanted to go back to our requirements, it'll automatically save. And as I look at the requirements, I can now see that Hot Shot Fitness has been traced. That little T right there tells me that this has been traced. Now, that's not the only indicator. As if we wanted to look at the entity view of this, we can certainly see that this has also been traced here. So we have a verification that it has been traced. But at least if we're working in the requirements view, we do see that this has been traced. If a requirement has been satisfied, which tends to be a little further down the road when we're starting getting into test plans and verification reports, you can certainly look. There'll be an S that also pops up there, and when a requirement is verified after testing, you'll see that a V is also popped up there, or you can actually verify it with any type of other statement from a document or from another test that you may not have done, or some type of data that you may have found within searching through the internet. So again, those are just things of being able to show how you can actually do traceability, how you can do satisfaction. And satisfaction is pretty much as if you want to look at the we're going to go to a test plan. So if we just start up a test plan, hotshot PT test, certainly do this. Don't need a number. We'll just start with a guideline here, and we do have guidelines. The CDC is from the Center for Disease and Control. That was for a customer I think we were working with that was looking for some type of biological guideline for their testing. So we can certainly do with guidelines, and we'll push that out. And it'll give us a template in our documents view, much like requirements view. The nice thing here is that you have the hierarchy over on the left-hand side, all hyperlinks, so you can go to the areas that you want to look at. So if I want to look at the functional testing, just click on that, and it brings me over here. And then I can start looking at how I want to start testing. So as I'm testing these parameters or my requirements against my test, and start writing my test plan based on some of the models that I've created or anything like that, as I get the data from the testing, I can start then verifying that the requirement meets the test data performed by a certain action, and it goes all the way back to the requirements view. So it's certainly a very useful tool when we're talking about looking at your satisfaction, your requirements, and your traceability and your ability to verify your requirements as well. So as we're looking at the requirements, you can certainly, you'll be able to see what's been verified, how it's been traced, just by going through that. So back to the test plan. So again, I can certainly do compatibility testing. I can certainly put in my risks and issues here, which will also create, I can create risk categories, and that'll give me a risk matrix. Certainly, and these are all editable just like the requirements view, so I can certainly add in something like hot shots must be able to walk in arduous terrain with 50 pounds of weight for 3 miles in less than 1 hour or something like that. That can certainly be added in. And then we can start adding risks to these test risks and issues where the arduous terrain is now the risk based on, you could turn your ankle, you could certainly roll your ankles, you could fall down a 60% incline of a steep hill. The weight could be too much and you could actually overexert yourself, strain your back. There's a lot of things that can happen during, as part of this risk. So really in actuality, the test risk would be the arduous terrain as one, and then I can start adding more children to that here if I wanted to start listing other things. So dehydration, physical injury, those types of things that can actually get in the way of actual doing some type of doing the test itself. So we can certainly do that, and then as we look at this, we can now take a look at the entity view, and we can then over here, and then we can look at the all. We can do specify by characteristic. So the characteristic could be, actually we're going to add a new one, so new characteristic. Terrain would be a 60% slope. Terrain can be arduous at times with up to 60% slope. And then we can give it a value or units if there was something that you had to put in there. And then once we're done, we just hit submit. So now we can actually show that it's been specified by a characteristic, and so we can start doing all of this type of relationship values back to all the way back to our requirements as we start working through Innoslate, and these are fairly simple to do. So if I wanted to again add another statement here, employment, I'm just doing stuff to add stuff here. So again, that's traced back, and then we want. So again, we can also do the causes risk here. So we can also add in the bodily injury, the arduous terrain as part of that, and then the one that I want, but that's okay. That's okay. So basically, that's typically how we can work through the tool to show. Again, so you see the traceability has been done here back to employment, the hotshot fitness, and whatnot. So, so as we do the testing of that test plan, we can then start testing it back to our actions as we start building a model after this. So that's why we talked about. That's why we talked about being able to trace and the many different ways to be able to do that. So if we wanted to actually look at a different way of doing that, we can certainly go, for the diagrams. So again, we have the traceability spider diagram here, but you can also see the hierarchical comparison here. So we'll do these are all relationships, so that's what you want to look at. So this is our hierarchical relationship here. You can see, and this is all interactable. So if you saw something that didn't quite fit, employment, hotshots, PT guide to employment. So we can certainly add that in. Fitness qualification. There is additional testing for hotshots. They have to go through some basic training. This is all part of their guide to employment, even though it's part of the physical training. But I'm just showing you that it's interactive, and you can certainly bring the label this out that way in order to compare it to other areas that are traced to. So let's go back to requirements view. We'll go back to the show here, the slideshow, So traceability, I showed you the spider diagram. We have the requirement traceability matrix and the traceability and verification matrix. We also have entity view tracing. I did show you how to do it in entity view just by creating the relationship of the trace to statement or trace to many. Once you create that relationship, that T will then show up, and you can also view that as well within the spider diagram or in the hierarchy diagram, the tree diagrams. In multiple views, you'll be able to certainly view traceability of requirements to other entities within the tool. Spider diagram is the most effective one. So let me get back to the requirements traceability matrix. So if we wanted to do that, we can certainly do the report, and we can do just a traceability output. It's going to come out in a XLSX file or an Excel file, so we can certainly create that, and you should be able to, so we'll see the download here, and then you'll see it come out here. And this is just if you wanted to be able to, to show someone, or at least put it in a report of some sort, of how you wanted to do this. So we'll extend all these, just so you can see it here. But with a red just means there's nothing that's been put into that, but you can see that there's the trace to relationship has been described, and it shows you, which one's been actually traced to. So which requirement has been traced to. In this case, the test risks and issues, and Hotshot's PT Guide to Employment. So you can see how that's been traced out to. So it's fairly simple, and we can certainly bring this back in and back out if we wanted to. And the verification traceability matrix is done the same exact way. It's just going to show you the verification between the two relationships as well. Same with the satisfaction matrix. So it's, again, it's the same format. It'll be an Excel file that'll be able to, that'll be put out this way, and you'll be able to actually use this for reports or, for any type of presentation you need. You can also use Innoslate for any type of presentation. So as we're working through our relationships, these will get bigger, and you'll be able to see which ones are not traced to, as it defaults to the red color. So it makes it a little more feasible for being able to do those types of things. So after requirements, what can you do? Well, there's a lot of stuff that you can do after requirements. It's not the be-all, end-all. There are companies that just want requirements, and that's what they want to do, and that's fine. We have no problem with that. But we do know that as system engineers, that requirements can be modeled, and there are actions that can actually perform those requirements, and you can start assigning resources or assets, which are people who perform those actions, and then that can actually be brought into your test plans, where those people can then actually test the model once you've got a successful result, and you can simulate the model that you build in order to actually show a good simulation of the numbers you're expecting, an executable version of just how you envision the test to go. I mean, it could be very easy to certainly bring you into a model. So if we look at, we'll go to diagrams view, and I know I don't have any action model, so I just want to create an action diagram. So basic fitness test. So the branches load up. Again, this is drag and drop, so I can certainly do, here, and then candidate, or give candidate weight pack. Okay, and then we'll continue to build it. Very simple type stuff here. Line up at starting line. And then, you can start doing these things, and this will all actually trace back to the basic fitness test as actions that are performed that the requirement satisfies, or actions that satisfy the requirement. So conduct fitness test. And then, we can certainly decompose this if we wanted to. So we can open the decomposition diagram, and I can outline the entire composition or the entire fitness test here, which is 45-pound pack on your back for 45 minutes. You got to walk 3 miles in under that 45 minutes. If so, you pass the basic fitness test. Fairly simple, and we can certainly build it that way. And I'll just throw a couple actions on here so you can actually just see how we do this. And so now you'll see in the parent diagram that this is now decomposed, and if I just click on that, it'll bring me to the actual decomposition of that. So I can create multiple levels of the organization of actions or requirements and be able to show the complexity as I go down to each level and actually get into the weeds and start showing requirements built into those areas as well. So it doesn't just stop at a very high level. It can certainly go beyond, and we can decompose to any level you want just about in Innoslate. So as we're looking at that, so again, this is going through just pretty much the entire life cycle. This is what requirements builds up, is the entire system engineering life cycle, all the way from design and your concept out to operations and support into decommissioning of the product. And these are the things that we do as system engineers in order to make sure that one, we're running it efficiently, but two, that our requirements are being met. And it's the stakeholder requirements that are being met, as well as building into our functional requirements and our our system level requirements, and those types of areas are being met and traced to the actions that are doing this, so we can actually have an effective test plan written out when we go out to the field or when we go into a lab and start testing, that we can then start testing the product against the requirements and see if we need to adjust the requirements to make the product work how we want it to work. And that's all part of the engineering process, and this is all part of the system engineering process that goes with it. Now you see here we have program management listed under here. Program management is also built into Innoslate. It actually overlaps 90% or about 80% of the system engineering process. But we've certainly locked in ways to be able to create process flows. This is one way. You can also do a sequence diagram, which can give you certain areas similar to Microsoft Project, and how you can actually create your process flows as well. So as we're looking at requirements and just doing that, requirements alone is what's going to start this. So you can have a requirement of, well, we need to build a product that, and here's our requirements, but we have a cost requirement of $10 million, and we can't go over it. And so now you're going to start tracking your costs based on your models to see how much it's going to cost to build that product, and make sure you come under that and see where you can actually identify your gaps. You can start to identify where you need resources, where you need new assets, where you need more production, where you may need more money to be put into one area and not another. And as project managers, we can certainly, at least within Innoslate, we can also branch out, so we can handle cost alone on our end, and the people that don't need to see our cost can actually see that on the other end. And that's usually just done. We have here the branching and forking. So I can select certain entities off of this database table or database here, and then I can actually create a new project, give it a name, create and go, branch it out, and then send it to the person that I want working on that, and they will never see any of the cost data that I have and that I'm working with. So you can certainly do it that way as well. So as far as requirements, again, as I'm looking at this fitness qualification, and I want to go back into the entity view just to beef it up a little bit. So you can see here that was it clear? Well, more one modal verb may lead to ambiguity or confusion. There's that word, ambiguity. So I probably need to certainly work on this requirement just to get it so it's not ambiguous or reduce the modal verbs. But I can certainly say, well, it's consistent, build it up a little bit. My requirement may not be directed to a given system or service. Okay. And traceable. So as you can see, my score has gone up. I've improved it a little bit, but this is all part of the requirements analysis. And so as I go back to my requirements, Even though the scores aren't properly where I want them, at this point, I just say, well, this is a good foundation for me to get started with, so we're going to go ahead and baseline that. And then we'll create the baseline. And now it's changed all to blue, just a color identifier to let you know that it's been baselined. You can still see all the hierarchy and the scores, and I can still edit these. Once I edit these, though, the baseline changes. And with the baseline, I've now created a version history, so I can always revert back to this if I want to when it changes. Each entity also has a version history. So if we go into entity view, you can certainly see the history here, and you can see how many times I've changed that entity. And when I open it up, you can see what's actually been changed within it. So the relationship was added. There were no changes to the attributes, and there was no labels added. If I wanted to revert to it, I can certainly do that just by clicking this revert to, and it'll bring it back to that version. If I wanted to categorize this as a certain requirement, so employment, well, this is an actual performance requirement. Yeah, sure, but you can also create your own labels over here, but this gives me a way to sort certain requirements into multiple areas. So if I wanted to say this is a function requirement, a performance requirement, and a reliability requirement, just because we need to know that they're reliable enough to pass the basic test, and it also has the auto one brought in. But as we look at those requirements or those types of labels, we can then go to our database, and you'll see that these have been added, and now I can actually sort by that label if I want to, just by going down here, and then you see all these types of different labels here. So we just go to the requirements class, and I can sort by function requirement, and it shows me the actual one that's there. So again, it's very powerful in being able to make our lives a little bit easier when we're having to do sorting, searching through. Our search engine on this is very powerful. We have basically it looks up keywords, and you can find it throughout the entire project. So being able to branch and fork to bring in program management, as well as just being able to do requirements management and analysis with, and as you can see, I changed the employment one, so it went back to the yellow color, orange color, and so now my baseline has changed. So as we're looking, so as we're looking at this, I can always go back to my baseline and see now it went back to blue because I didn't add the labels over here, but you saw the labels on the other one, which show over here. Now this can also be exported as a document if you need be, or you can go over here to export the document. You can certainly view other diagrams in here, so if you wanted to see the document tree diagram, I think it's a cool diagram. Again, this is interactable, so if you wanted to add a requirement, you can certainly do so, and it starts creating the chain down, certainly with the hierarchy involved. And then again, you can also do your attributes over here as well. So there's multiple ways of tracing this out. There's multiple ways of being able to add in new requirements and build onto it to create the decomposition to get down to the weeds of requirements needed for any type of project, large or small. Innoslate was built for that. It scales very well. It's the scalability rate of this is 10 million entities in one project with 500 concurrent users, and Innoslate barely skips a beat. So being able to work with a tool of that magnitude and being able to work with projects large or small in which the tool won't get bogged down on a desktop is certainly an advantage, especially when you're dealing with 10,000 requirements in one specific setting. So again, very powerful tool. So with that, I think might be at the point just where we're going to summarize kind of what we did today. Requirements management analysis is one of the initial steps after the concept phase. There are different types of requirements that can be applied to any project, and Innoslate is able to identify these types of requirements in multiple ways. And I think I showed that with the labels, as well as just you can certainly make it a make anything but just as a functional requirements document or a system level requirements document. Writing good requirements is important for the success of the product and the life cycle. If you don't have good requirements, you're likely going to have a bad product, and it's going to have to go back to the requirements phase in order to elaborate on those requirements and make them a little more complete and a little more functional towards the product you're trying to build. Analyze requirements to be individual statements, resolves ambiguity and duplication, which creates more work for verification and testing purposes. I'm sorry, there's probably a comma missing there, but it says that basically breaking them down into individual statements to resolve ambiguity and duplication. I think it's meant to say that ambiguity and duplication creates more work for verification and testing purposes. So if we actually analyze requirements and break them out into individual statements and avoid conjunctions, that's certainly the path that you want to take. There's more to requirements than just writing them and analyzing them. Program management and system engineering methods can be applied after requirements management and analysis for a more detailed look into your product and its success. The more data you have, the more refined your test process can be. There are many tools that apply multiple add-ons for extra costs to do what Innoslate can do, and one tool for a fraction of the cost. These tools are complex and tend to be difficult to use. Some think Innoslate's very difficult. I find it very intuitive. And even though I've been using it for, I think, 5 years now, when we come up with new features, I still find them to be very intuitive, and I think that's the thought process as we go into using Innoslate, especially when we're talking about requirements. And our cloud or enterprise versions are available with the same capabilities. They pretty much mirror each other. So with that being said, I think I'm done and I can answer questions.
Thanks, Mike. We've already received several questions. If you haven't done so, please send your questions to the panel on the right. Mike will answer as many questions as he can before our time is up. If we can't get to your question today, we will contact you after the webinar. I'll give everyone a couple of moments to write some questions in, and then we'll get started. Okay, so our first question is, are you saying the requirement software can double as a project plan for workflow management, such as do we have PERT charts, Gantt charts, budgets, variance analysis? If so, can cost be tracked at the requirements level?
That's a very good question. We do have Gantt charts that run through when we run our simulator based off the action diagram. It actually, the output of it is a Gantt chart, and you can see cost as it's allocated per resource within our simulator. What I'll do is I'll at least let me see if I can get to an actual project that we've got that I know will simulate here. I can't remember which one it is, but this one here. So if we go to a diagram, and basically our simulator is meant to cover the areas of program management in which you want to see cost, as well as some of the other areas that you talked about, so schedules, and you can create an actual schedule in our simulator to go along with. So as you're creating your action diagram, you can certainly create start dates for those, and when you simulate it, you'll actually have you'll see the Gantt chart show you when it started. Wow, this is taking a long time. Different one here. There's nothing in there. Anyway, so as we build the action diagram and we actually run the simulator, it'll certainly show you the Gantt chart, which will show you your schedule for one. You can do it as your personnel schedule, your workflow schedule, You can certainly do cost as an entity within the database, and that will allow you to add that into the action that it incurs a cost, and so you can start showing how your how your cost is over time based on the performance. I don't know why this is not loading. So as you do that, you'll also get time constraints. You can do different time variables with this. You can run a distribution. You can run a specific time frame, and that'll also be figured in when you're doing your simulation. So as you create the model of whatever workflow process you're working through, you can add all of this data into it and simulate, and you'll be able to get the export of cost over time, resources used over time, how many resources were used over time. I don't understand, all my diagrams aren't working. You'll be able to let's just go to the database. If I have any action, I do have an action. So we're going to go to okay. Anyway, so you'll be able to see the action, the workflow process work through the simulation, and you'll get the export that you need. And you can also customize the export to show how many resources were used, what kind of resources were used, being able to show, and then you can start tracing that all back to the actions, and then being able to show these as really wanted to get into an action diagram. Yep, okay. So like I said, you'll be able to see, here's your Gantt chart. You'll see total cost, see total time it takes for the actual thing to run through. We do have a 3D version of which shows how the process runs through the actual simulator, so you can see which processes actually it takes. You can also manipulate the processes with scripts, and we have some already built-in scripts for you with probabilities and you can alter the probability number of which path it can take if you have a decision point. So you can certainly do that as well. And you can also see the status over here, but you can add more blocks. You'll see time, resources, and others over here. So if you wanted to see the console, if there's a tree map that you wanted to see, you can certainly see it over here. So you'll see a time tree map as well. And it's just as easy as running it. This will not execute because it's got one. If it does, it's just going to show you one thing. But I don't expect it to execute just because it's got one in any. But I just wanted to show you. There we go. Yeah. So the time it took, 1 hour. There was no cost tied to it. So, but you can certainly use it for any type of management or oversight that you want as you're using the tool.
Thanks, Mike. I'm going to go on to our next question. How do I make a requirement verification matrix in which you determine which verification method, test, demonstration, analysis, inspection, and/or modeling and simulation you're using to verify a requirement?
That's a pretty good question. Let's see. So, all right. So if we go back to our requirements view, let's go back to, well, requirements here. Yep. So if we go back to the requirements view here, this is very expansive requirements for landing gear. But if you wanted to make a requirements verification matrix, all you have to do is go to your report, and then here's your verification matrix. And when you run this, basically, it's going to come out in Excel format. I don't know if there's anything that's verified on this or not, but we'll find out. So again, it'll pop up. Yeah, that's probably no, there's stuff there. So these have all been verified. The ones that are not in red are verified are verified. So you can down a little bit. And this is just to show you that there are some that have been verified. So as you look at this, there are some that have been verified here. And then as we look back at it, this is the verification matrix that you've got. So the use of proximity sensors for gear position safety switches is common, and that's been verified by the action, approved by me or Mike, whoever. So you can see that that's how it's going to lay out once you've done your verification process. Now, as you verify this, if you look at the actual requirement, if the gear, so like this one, if the gear fails to extend, some sort of unlatching device is used to release the up locks and allow the gear to free fall. So as we do that, basically as we're looking at this, this will then be brought to your test plan. So as we go to the test plan, here. I did this for another customer, but it was painting a room. But if we brought this in the test plan, we can certainly go into a functional. It would have to be a functional testing. Performance testing would be the better one. And then we basically item to be tested. We put in there the landing gear locking mechanisms, and then we just basically go into the test approach, what we're going to do with the test, how we're going to do it, what's the fail criteria, what's our entry and exit criteria, so what do we consider, you know, for it to be a success, those types of things. And, you know, we can certainly add and change any of this to do that, but once we actually create something within this, within here, we can then go into entity view, and then we want to that's eventually going to go to, I'm sorry, that's eventually going to go into our IV&V plan, and just doing this for it right now. So again, PDC is our favorite. So then we can go back into our verification, what we did, you know, any type of this, and we can go into our constraints, certainly go into the entity view, and then we should be able to get that's funny, I never see my verified by. Like I'm doing it wrong. But we'll certainly see a verified by or something of that nature, so you can actually get that brought into your verification matrix. So basically once you get it verified, which for some reason it's escaping my mind at the moment. Well, I can easily do this. I look up the schema editor and relations. See what verified by identifies the entity that supports the requirement and identifies the requirement that supported by this entity. Yeah, so basically I would take anything from the test plan or an action and have it be verified back to the requirement, saying that it's actually been verified against the test plan. And that'll show up in your actual requirements verification matrix. So right there, so as you can see, this has been verified by, so there's the V right there. Just much like the T was there before, so I can see that that's been verified. But that's typically how you're going to run it. You'll take your requirement, do your model off the requirements, put it into test plan, put it into verification, and then have that all traced back to the action that's been verified, or that verifies the requirement has been met. I think I answered half of the question. It might have been.
We have one more question. Okay. Is there a trial of this software?
Yes, we do have a free version of the tool, which allows you up to 200 entities, and that's all the time. But we do also have a professional trial that you can demo for 30 days. And you can just request for that on the website, and once we get the email for that, then we just upgrade you for 30 days, and you can play to your heart's content with Innoslate and you know, play with it with the full version of it. Now, mind you, it's on the cloud, so I would not putting any type of actual data you don't want out on the cloud. So, but it's completely at your discretion.
Well, thanks, Mike. We actually did just get another question. It's a question about how do you create labels and how do you do bulk labels as well?
Okay, so in the database, we have plenty of, you can see multiple entities here, and if I wanted to actually create a bulk label with them, I can certainly do, and all I did with that is just hold shift down to the entity that I wanted to get to, and then I can just add the bulk label if there was, so functional, oops, if I had a bulk label, if I had a label here. Let's start with this first. So to create a label, if you wanted to, you can certainly, you go to Menu, Schema Editor, and you go over to Labels. It shows you all the labels that we have within the tool. So I would search that first just to make sure we don't have it. And if you still need to create a new label, just create one here. We'll go to New Label Test just for, you can certainly choose to hide it, link it. You can give it a class that it's tied to, so any one of these classes if you wanted to requirements. You can also give it a parent label if you wanted to, certainly tie it into another label that it can be used with. And then the link label, if you want to link to something or not, typically I haven't used that. But you can also give the label a description just so you know what it means. So then as we save it, what I can do is I can go back to my database and select all this stuff for whatever I want. Oops. Go back up here. And then we can add the bulk label, new label test, so it shows up there. And then now all the labels have been added. So that's the way to show bulk label adding.
Thanks, Mike. We just got another question just came in. How do you create a test plan and how do you create a relationship, a connection with the requirements document?
To the test plan?
Mm-hmm.
Okay, so as we have our requirements deck here, basically as you take these requirements, what you're going to end up doing is taking these requirements and you're going to actually create an action model off of these requirements, which will then allow you to simulate and then bring you into your testing realm. So as you're starting to come up the V and starting to test process, that's pretty much the straight and narrow of how it goes. Now, as we look at this, we can certainly go to, I don't know if my diagrams view will show up, depends on the amount of diagrams available. But as we were doing, as we looked at the requirements, oh, there we go. As we look at the requirements, basically what we're going to do is we're going to take the requirements and then we're going to certainly analyze them, and then we're going to look at the requirements and see what actions can be done, maybe to satisfy this requirement. So a large aircraft retraction systems are nearly always powered by hydraulics. So how we're going to do that is we're actually going to model the aircraft retraction system based on the hydraulics, and we can then show decision points within that model. So what we want to do is we go to diagrams, create a new diagram, action diagram, and here, this is what this is about. And so as we create this action model, there's multiple ways that I can think of how I'd want to do this. I can create a big parallel and have different parts run into different areas and use triggers to select different parts to start working at different times, or I can create a linear model with decision points as well. So I mean, the easiest way is just to start creating a linear model and then working from there. So as we start creating our action model here, engage landing gear, something like that, and then we just keep building on this. Hydraulic hydraulics, engaged, or pressurized, I should say. Pressurized. Okay. Now, actually, I want to remove that. Now I have a decision point, and now my decision point can be certainly hydraulics fully pressurized. Okay, and now that I have that question mark, that lets me know, well, yes, okay, if they're fully pressurized, the landing gear should come down properly. And if not, I can always retry it, or I can use the manual lever to get it to drop on its own. So as we do the action diagram here, then what we're going to want to do, as we save this, as we save that, then what we're going to want to do is we're actually going to want to go to the test plan, and we can create a new test plan going here, and I can create the new test plan document. So testing hydraulic landing gear system, and now here's the key. If I have a template that I already like, that I want to use, I can certainly create it in Innoslate. And I can create a blank document here, which basically will be just a white piece of paper, but I can start adding in test statements to this document in order to be able to create my own template. Then I save it and export it, and then I can use it on another project if I ever wanted to. So that's the allow for the blank template here. But if I wanted to use another one, I can certainly use some of the ones that we've got here and just edit them as I go. So I'm just going to use another one here, and then as it's creating my test plan here, which is right there, I can edit these as much as I want. I can certainly take out the version history if I don't like it. I do like version histories because it gives me an idea of who's updated the document, what version it is, and who's done it. I can certainly edit this, and this is all exportable into Microsoft DocX. Any images that you put in here will be exported to the report. Any tables will be put into the report, et cetera, et cetera. You put it in, it can certainly be brought out into the export. So I'm going to start going into, purpose of the test plan document. I can write up why I'm testing this equipment, mainly safety of an airline or an aircraft as it's coming in for a landing. We want to make sure the hydraulics pressurized to a certain PSI in order for the landing gear to engage and stay engaged. Otherwise, we have to, go for the fail-safe measure of, engaging it with a manual drop. So items to be tested, I can certainly add in, the item to test would be, the front hydraulic system, the two rear hydraulic systems, those types of areas. Write in my test approach, what's criteria, is there anything, what's the pass-fail, and that's, in this case for me, that would be just meeting the PSI and ensuring that it drops and locks. If it doesn't drop and lock, in a controlled manner with the hydraulics pressurized to that PSI, then we got to test it again. We got to figure out what the problem was. And then, again, that's the test entry and exit criteria. So, and our deliverables will be the reports, the data reports on the pressurization, those types of things. And if it actually fully locked, what happened when the plane tried to land with it fully pressurized, and did the landing gear buckle under the weight of the plane? Was it not pressurized completely, or did it lose pressure prior to any point of the landing process? So, you can certainly suspend your test based on poor results and then resume it when there's a lot of different areas that you can certainly do this, add into this. And basically what you're going to do is you're going to take this, take this part of the test plan, and you're going to then, I have to remember which one it says. You can then trace it to, you should be able to trace it to an action. So again, hydraulics fully pressurized. If it was, basically if it was the test, one of the test criteria, you can certainly trace it to that action. If it's fully pressurized, you add that, and then you go to this, and you want to basically have it go to. You can have it include the action, another action if need be. You can also have it performed by the asset. So if there's a pilot that does this, or there's a certain system that does this, you can also have it being performed by. You can have it related to the action, relates to the action, or you can have it verify the requirement, which is where we were going to go before. And so we just go back to the requirement. So again. This is the requirement I think that I did, but we're also going to do a few more just so you can see it. So now I've got all of these tied into it, and so now you can see that these are verified requirements. So we went back to the requirements deck, and you saw so large attraction aircraft systems. So there's the V that's been verified. We saw that one before. There's the other verifications. So then all we have to do, go back to our report. We can do a verification matrix or verification traceability matrix and get the same output, and we create again, so you can see hydraulically pressurized large aircraft retraction system. This requirement, it's actually not a requirement, it's a statement, but for this purpose, this requirement has been verified by the action that the hydraulic is fully pressurized, and you can run through that. We can also look down here. I think I only traced it that one action, but I can add other actions into this to show that. So that's pretty much how you would run through it as far as creating your requirements deck, creating your action model, going to your test plan, and then actually verifying the test plan back to the action, tracing it back to the action, and having the action verified by the requirement. And that's pretty much how you would run that. And then all you have to do is create your verification matrix here, and it's pretty much the whole process.
Well, thank you, Mike. Unfortunately, that's all the questions that we have time for today. If we didn't get to your questions, we promise we'll email you after the webinar, and we'll get your questions answered. We would like to thank you again for joining us for today's webinar. As a reminder, we will be following up with you very soon to send you a link to the recording. We also encourage you to visit our website and our blog, as well as connect with us on social media. That concludes today's presentation. Thank you again for your attendance. Please enjoy the rest of your day.